Okay. So yesterday, what did we do is we just we understood how to create a meta store, and we understood how to attach that meta store to the workspace, and we understood how to create a catalog, and we understood how to create a schema with the required path. Okay. And we understood how to create a volume. Hmm. So today we'll just try to, and after that I created a table and I started inserting the data into that table, and how backend things work, that also explained. Okay. Now today I'll just try to explain when you do DML operation, that is update or delete operation, what happens in the backend. I mean, same whatever we understood it in the Delta files, right? In the same way we'll try to do it. Okay. Same concept only, but I will not take much time here. I'll quickly wrap it up. So yesterday we have loaded the basic data, the 17 records into the table, right? So once we loaded that data, I told you already, your insert command, equivalent command in PySpark is insert command in SQL. The equivalent command in PySpark is writing the data in a with append mode. Okay, df dot write dot mode of append save as table. See, these activities we do it regularly, guys. You guys have to like by heart this reading the data, writing the data to the destinations. Okay. So you have to by heart the syntax. I cannot do anything for that if you don't practice it. Okay. Huh. So if you want to read the data, you can read it in SQL format as well. Or if you want to read in PySpark format, I told you spark.read.table. Our read is also not required. Directly we can use spark.table of also we can do it. Okay. So it will execute, no problem. So usually I use this syntax only in real time. Okay. Currently I think we don't have any data. Don't we have any data in the table? Yes, we do have, right? We do have data, right? Oh, I think I recreated the table. I think I just executed. Oh, my bad. I recreated the data, guys. I'm sorry. Okay, let me go ahead and check actually in the back end the files got deleted or not. Where do I check that one? I'll just open this storage account here. Okay, this is the one. And let me navigate to the table path. Okay, so inside this storage account, we need to open the containers, and the branch schema data actually stores in a branch folder, and unity storage schemas under the schema tables. This is the employee table schema, sorry, unique identifier. So we have some data 2.65 kilobytes because the time travel is enabled, right? That is the reason still it is actually pointing to this one. Okay. So, but when you try to query it, actually, it doesn't show anything. Okay. Anyway, we'll try to see that one. So I'm just trying to execute the describe extended on the table. Okay. Let's see what happens here. It will actually give you um, the table structure, and along with that actually where exactly this table is stored. I mean, what is the backend location of this particular table, what kind of table it is, and this table is created under which catalog, under which see, I told you, right, scheme under which schema they call it as a database case, but do not get confusion with the database and schema terminology. For now, you consider only schema. Don't think of database. Okay, the table name is this one. Table created on so and so date, and these are all the table properties. All these things you can see with the help of describe extended table command. Okay, and I told you already one more command, one more very important command which we regularly use in real time is history command. Okay, I mean, if you want to restore the data, we use this command actually. Not every time. Whenever we have to restore the data, right? Something goes wrong, we have to restore the data actually. At that time, like we use this command. Okay. So just use the history, describe history table. So I think just now I created the table, right? Oh. So it is showing, yeah, create or replace. Yesterday I created the table and I wrote the data. Because of that time travel, actually, the data is not yet deleted in the backend location, but still it is not, currently it is not pointing anything. When we do select star from table, it is not showing up any data. Though it is like has that Parquet file, it doesn't show any data because we just recreated the table, right? Okay. So create or replace command we ran. That is the reason why it is showing the version as 2. Okay. And now we have to start like inserting the data to that one to the table. So for that, what I will do is I'll just try to read the data from the location that I've done yesterday. I'm just storing my data in the data frame here. That's it. I'm not doing anything. I'm reading the data from this location. Okay. I'm reading the and storing it in a DF. That DF data, I'll just write it into this table. So save as table will write the data to the table. It is as simple as like your insert command. Okay. When you write here overwrite, it will truncate and load it. Okay. Don't use the overwrite command here unless until you have a requirement to truncate the table. Okay. So let me execute this one and see what is happening here. Or can we create another table so that it will be easy for us to understand the from the scratch? Is that okay to create another table?
Okay, sir.
Because like
Okay.
we already
Yes, sir.
have the Parquet file, right? I wanted to create actually a new table. Okay. I'm just creating some dummy table emp underscore Shiva. Anything you can take, no problem here. Just copy this one and try to create this table here. I'm just copying the table name, guys. That's it. Okay. And when you uh, extended, oh, extended anyway, you guys know, right? Hmm. So when you run this command, it will show up actually all the all the column names and the where exactly it is creating everything. It will try to show here. Okay, and it is managed table. Today, I'll try to show you the external tables as well. Okay, I'll show you the difference between them and describe history. Since I created it first time, this table. Oh, sorry. Underscore this one, right? Sorry, my bad. Underscore Shiva. You can take any naming convention, guys. No problem. EMP underscore test we could have taken. That's okay, fine. So it has created the version 0 here. Okay, in version 0, we don't have any data. Okay, now let me go ahead and start inserting the data to this one. I created anyway data from here, right? Now let me try to replace this table with the EMP underscore Shiva and let me start like loading the data into that. Okay, so what is your expectation here? Back end, what happened? What will happen? What is your expectation? Tables. So the table is created. This table is created actually. This is the employee one. See, I can see one Parquet file here. That means because I just loaded the data, right? That is the reason why I see one Parquet file here. And backend, when you create the table, it has created one CRC and one JSON file. Now, since I dumped the data here, it just incremented by one here. That's it. Okay. Now, what I will do is just remind me, guys. Uh, I can read the data like this. Just remind me, like everywhere I have to replace this EMP underscore Shiva. Okay. See here. So I can read the data spark dot table of this particular table. Spark dot read is not required. It's up to you whether you wanted to use read or not. That's up to you. Spark dot table of this particular table. Okay. And I'm able to read the data and select star from EMP. You can use this command or you can use this command also. In PySpark way, if you want to read the data, use this approach. In SQL approach, if you want to read the data, use this approach. Okay. Yeah, that is fine. And okay, now what I'll do is I'll start inserting the data to this table. Um, okay, I need to change the table name right here. So just use here. EMP underscore Shiva. Now just insert this. What is your expectation here? What will happen in the backend when you start inserting the data to this? Two records got inserted. What will happen? Come on, guys. Two more files got added here. Apart from that, one more Parquet file got created here, 2.03 kilobytes. Uh-huh. Now where do we check like whether this file got added or not? Where do we check that one? Where do we check that one? In the Delta log, if you read that JSON files, it will keep tracking that information, which file it has added. In that file, how many records are there? What is the maximum value in that file? What is the minimum value of each column in that file? Everything will be captured with this JSON file. Okay, so that is what we have discussed already. Now, if you want, I can insert a few more records here. Yeah, I'm just trying to insert few more records. Oh, sorry. EMP table, we need to change it, right? EMP Shiva. And I'm inserting here. One more file will get created. Now see here, just refresh it. So 3 also got created here. Now CRC file also got created here. And now if I go to the backend, now see one more Parquet. See, the point I wanted to highlight here is, as you keep inserting the data to the table, it keeps adding the Parquet files. So this is what the one of the Delta Lake feature, right, that I've discussed. So Delta Lake is nothing but it simply scales up the metadata and the data files. That's it. As you keep inserting. Okay. Yeah. So that is about the insert operation. Now, before I go and discuss about the update operation, I just wanted to discuss about the delete operation here. Okay. So I don't want to use this department number 10 here. The table name I'm just trying to use here, employee Shiva. Okay. The first time whenever I inserted, right, from this record, I just wanted to update the salary of one of the employee and what is happening in the backend. That's what I wanted to understand. Okay. So where is the king employee? Where is this guy? Okay, I think I don't have that one. That's fine. Let's say I'll take the Smith record here. Smith record salary, I just wanted to increase it to 1,000. Or I wanted to delete this particular record. So we are discussing about the delete operation, right? Okay. I wanted to delete this particular record here. What happens? So where employee number equal to 7369, right? I'm just trying to do that one here. Delete where? EMP number or employee number? Employee number equal to 7369. Now let me perform the delete operation. Correct? 7369. Smith. 7369. Correct. I could have copied it. That's okay. Fine. Now let me execute this one and see what is happening. So currently we have 3 files, guys. 3 files, only 3 files. If you want, I can take the snapshot of this. I can take this one. I can take the snapshot of this one. Yeah. Now what happens when you do that operation here? What is your expectation here? What did we discuss in the Delta files? What happens when you do update operation or delete operation?
Deletion vector is got
Created.
Yes. Yes. What is the deletion vector actually? The deletion vector is created here. So if you want, you can check the, sorry. You can compare the file names here. The same file names, whatever you see here, exactly same. Okay, 775C2, 775C2, 9622, 9622, and 3F19, 3F19. Same files are there. Now, what could have happened in the backend?
So it will consolidate earlier Parquet files while reading, right? It
No,
will
no,
not
no, no, no. That will not happen every time. That's what I told you last
every
time.
time. Okay.
Uh,
Okay.
that depends on the what,
Depends on the
how many
uh,
records you're modifying, how many files are getting affected. That depends on that factor
the
actually.
huge volume of the data. Okay.
Mm-hmm.
For optimization, right?
So there is no guarantee that every time when you do delete operation or update operation, optimize will happen. There is no guarantee. Hmm.
Got
Now
it.
see, what is this deletion vector? Tell me first of all.
Employee Smith deletion is happened.
So it is saying that, boss, this is the record actually you deleted from the table. That record I'm just trying to maintain in this file. Okay. And this deletion vector is added to the first file, wherever the data is there in file, the deletion vector is added to that file. Okay. So what do you mean by that is, while let's consider, I think this is the file, right? This is the file, right? This is the file or not? This is the file or not?
Yeah.
Or if you want to read the data, delta log, if I go here and if I open this JSON file and show you, see, remove this particular file. Okay, let me download this and show you what is happening here. I'm just downloading this one. Okay, now let me open the Visual Studio Code here. Okay, here we can format the JSON file easily. So let me try to open that one, the Visual Studio. So this is the file actually. Now what I'll do is I'll just try to format the document. Now see what is happening here. What is happening here? It is simply deleting the file. Where is that remove option? See, it is deleting the existing file and it is rewriting. I mean, rewriting means like it is just copying the same file and it is trying to add the deletion vector to that one. A remove and one add. That's it. And it is adding the deletion vector to that file. That's it. What this deletion vector tells you is, hey, the Smith record is actually deleted from this file. Don't read that record. Don't read that record. That is what the meaning of this deletion vector. Are you getting my point? See here in this JSON tag, do you see this deletion vector? No, no, I don't see that. But here, when it adds the new file, it is simply adding the deletion vector to that. That's it. That means it is removing this file and it is adding this file along with the deletion vector. Agree? Agree?
Yes, sir.
Hmm. Okay. So this is what we discussed even in the Delta files as well. Okay. This is one thing. And one more thing is, I'll just. So since Harish is asking here, hey Shiva, optimize operation happened on the backend or not? Can you just let me know that? That is what he's asking actually. Now what I'll do is I'll just try to run this command, describe history command, so that we'll come to know easily backend optimize operation is happened or not. Okay, so this is what the command I'm just trying to execute here. Now see, only delete. Delete based on this particular filter condition. Predicate is nothing but filter condition. Okay. And here, if you want to see what is happening here, number of deletion vectors are actually added 1 and number of deleted rows are 1 here. Okay, that is what it is trying to give us the information here. Okay, so that is about the delete operation. Now let's go and perform the update operation here. So what we'll do is, this Ford salary or like Smith we already deleted, right? This Blake salary will just increase it to 2000 here. Only this record will change. Okay, so Blake, where ename equal to Blake. So what I'll do is I'll just try to do that update operation here. So update the employee underscore Shiva table. Okay, salary set salary equal to 2000, where employee ename equal to, so within single quotes, I'll just take here Blake. Okay, wait, what happened here? Just a second, guys. Mm. Now set salary equal to 2000, where employee name equal to Blake. Now see what happens here. Now what is your expectation here? What is your expectation? How many files will get created in the backend?
One more delete
One more?
vector. Delete deletion vector get created.
One more deletion vector will get added. That's correct. Absolutely right.
And one more Parquet file recording update will be created.
Only this record alone will
This
be
record.
loaded into another file, right?
Another file, yeah.
So, and one deletion vector will get added to the old Parquet file. Okay, wherever this record is there, to that Parquet file, one more deletion vector will get added. That's what we understood, right? Now let me try to do that one here. So set salary equal 2000, where ename equal to Blake. See, we don't need to understand this much of depth, but sometimes in the interviews they'll ask you, hey, like when you do one update command, what happens? When you do delete, what happens? So in order to like answer those questions, we have to understand all these things. Okay, now see, the number of affected rows are 1. Now let's go and see here how many. So I know that one CRC and one JSON file will get added here. And one more thing, 5 and 6 both got added. Because like optimize could have happened in the backend. Could have happened. And that too, remember here, after 6 transactions, one additional files you have to observe here. 1 to 6. Okay, I'll talk about this one. Now, what is happening in the data level that we have to understand? See, as we expected, okay, one more deletion vector got added, and one more thing is 2.65 for this file. Actually, this deletion vector got added to this file. On top of that one, optimize command happened. That is the reason why you see the data here, 2.69 kilobytes. This is the all this data, all the data which is present in all these files actually copied into this file. That is what the optimize command means. Okay, and once all the data from all these files got copied into this file, these files will not get deleted because the time travel is there. Once you travel back, it should be able to show you the backdated data, right? I mean, the old data, right? That is the reason why they don't delete these files, even though they copy that data into the new file. Are you getting my point? Are you getting my point?
Your total 3 files got generated.
One optimized file, one this
One deletion vector.
one deletion vector, and one
Okay.
deletion vector got added to the old file, right?
Yeah.
So what I will do is, instead of reading 6, actually, I'll just try to read the 5. Okay. So let me download this one. Okay. Now let me go here and let me try to read this particular file. This is the one. Right click and format the document. Now see here, you need to understand. See, this is this file is actually getting removed. Okay, along with the deletion vector. Okay, and it is adding this Parquet file with the same name. You have to observe one thing here. Same name it will try to same name it is trying to add here. Okay, and see, and it is adding one more file with the updates. How many records are there in that file? One record. What information is there? Whichever record we updated, that record with that record, one more extra file will get created. That is what we understood, right? See, it is removing the old file and it is adding one file with the updates, and it is adding one more file, I mean the old file along with the deletion vector again. Got my point?
Yes, sure.
Hmm. So this is what we need to understand about the deletion vectors. Now, so let's go back to the this one. What is that? The compacted file that it has created. Now, so what is happening here? See, these things actually you can see, but I don't know what is that compacted number it has set in the free trail account. Okay, and that too in the delta files. But at the table level, actually, for every 6 JSON, 6 CRC files, one compacted file will get created here. What do you mean by this one, Shiva? See, when you try to read that, let's say what I'll do is I'll just try to execute the command, select star from table. What it is supposed to do in the backend? Come on, you guys tell me. What it is supposed to do in the backend? Come on, come on, come on, come on, come on. Where is the select star from table? This is on. See, when I do select star from table, what will happen in the backend? You tell me. Come on.
You retrieve the data from all the respective parts.
Uh-huh. Okay. Let me tell you that one. See, what happens in the backend, it has to open all these files, whether, I mean, the meta, which file it has to read, whether you're using the filter condition or not. So, in order to execute your command with filter or without filter, it has to open all these files and it has to close it or not. In order to understand uh, the uh, in order to understand which files it has to read. Are you getting my point? So it has to open each and every file, and it has to note down actually which file it has to read, and it has to close these files. See, while if you are doing select star from table, back and it has to open lot of files and it has to close lot of files, right? So instead of doing that one, see, since it is the 6 files, that is okay. But what happens when you do in the real time, lot of insert operations or update operations or delete operations, hell lot of thousands of files will get created, right? Is it easy to open the thousands of files and is it easy to close all thousands of files? And again, on top of that, it has to display the data. Do you think that is a effective way to display the data? No. So for that reason only, what it does is instead of opening all these files every time, it will try to consolidate the data from all these files, or it will try to take the data from all these files and dump into one file, and it will start reading the data from only this file. It will not open these files and close these files. But going forward, when I do select star from table, it will simply start reading the data, the metadata actually from this file only. Because um, if you're opening a lot of files and closing a lot of files, that is metadata headache again. So 126 actually, I have copied all these files data into one single file. Going forward, when I do select star from table, it will read only from this for this file from this metadata file. That's it.
Is it every 6 files or it will depend?
It is set at the Unity catalog level actually. If you want to control that one, you can control that, but generally we don't do that. At Delta engine level, this is set. Okay. Not only this, like we have one more thing actually to discuss here. What I'll do is I'll keep writing the data to the table actually. Let me open some, I think, okay. Let me keep writing the data I have here, right? So what I'll do is I'll just try to, I wanted to execute this insert command multiple times. I wanted to execute the same insert command 20 times. How do I do that one? I wanted to execute this insert command 20 times. Shiva, select this one and like keep executing this one 20 times. Huh? No, programmatically I wanted to do that. How do you do that?
For loop.
For loop.
Yeah. For loop we can do. Now, okay. Come on, help me. So for loop means Python we have to use. Yeah. So what I wanted to do is I wanted to store this insert command in a variable. So insert underscore var equal to, if you have multi-line statements, what do you use in Python? Triple single quotes or triple double quotes, right? This is the Python fundamental command, right?
Yes, sir.
Correct or not? Now, so spark.sql insert var, this I can execute. Now on top of this one, I just wanted to use actually for loop for I in, okay. What I want 10 times or 20 times if you want to
Range.
execute means range of we can take it, right? So range of 1 comma 21. 20 times means 20 I mean ending number is excluded, right? So that is the reason 21 I'm taking here. Okay. Now what do you want to execute here? I just wanted to execute spark.sql of simple. This insert variable, whatever it is there, I'll just copy paste here. That's it. Can I do this? Can I do this? Okay, let me execute this one. See what is happening here. Yes, it is executing. Let's keep on executing. Hmm. I could have inserted print command here to see how many times it is iterating. Now back and what is happening, I just wanted to understand. Now see 11, so far 11th number is running, 12th number is running. It is taking this much of time. 13th, come on. 14th, see 7 to 12, one more compact file created, right?
Yes, yes.
For
It
every
will
6 files, yeah.
show. It will show the how many files it included.
It included, yes. From this number to this number. .compacted.json. Now one more thing. 7 to 12. Now 16th is running now. See, 13th to 18th is created. Yes. Now let me 13th to 18th. Now one more compacted file will get created now. +18, 6. How much? 24, huh? Now see, 19 to 24. Is it still running? Yeah, I think it's still running. See, I'm just trying to understand whether it is creating the files or not really. I don't know why it is taking this much of time. Maybe the cluster size. Still 26 is running. You can see the count, whether it is incrementing or not. I think this is completed, huh? Now that's fine. See here, every time 19 to 24. I think one more time I have to execute this one so that I'll show you one more compacted file on top of all these compacted files. Let me show you that.
How many deletion vectors created?
Deletion vectors will not come into picture here, right? Because we are inserting the data, right? We are not updating anything.
Okay. Sorry. Got it.
Okay, so I just keep incrementing this number here. 24 after 24, 24 to 30, one more the compact file will get created. See, 25 to 30. Okay. Now, one more thing that I wanted to, for every 36 files actually, one new file will get created actually. That's what I wanted to observe. After 36 files, I wanted to observe one thing. Thirty-four is running now. 34 still. 35. So now 36 is coming into picture. Yes. 24, 24, 25 to 30. Now see, this is what I'm expecting. This is what I'm expecting. See,
Checkpoint.
after 36 files, actually, one checkpoint file created. That means it has created the snapshot in the backend. Okay, so going forward, it will check from this file onwards. It is actually trying to take the data from all these compacted files and it is trying to keep it in checkpoint file. Okay, so I've captured the same thing in my document. Let me show you. This is what it is happening, guys, actually in the backend. Okay, so for every 6 files, actually, compacted JSON file will get created. Okay, and from now, after this is created, it will start reading the data from this file only. And after that, when you start doing the inserts or updates or deletes, it keeps creating that .json, .crc files. And after again 6 files, again it is going to create this one, and it is going to read the data from this file and the following files. After this update. Okay. So, and after that, 12 to 18, it will get like that. It will keep incrementing the files. Okay. After 36 files, actually, the checkpoint file will be created here. Okay. Just to improve the performance. That's it. Just to improve the performance. Because it has to read the data from all these small files. Actually, it's very difficult. These are metadata, of course, I know. This is not actual data, I know. But it's very difficult for Spark or Databricks to open these files and understand which files it has to read and what it has to do. It's very difficult, actually. So that is the reason why these files will get created. Now tell me, what is the conclusion here?
But Shiva, if we because inserting millions of data, right, or
Uh-huh.
then
Uh-huh.
so how it will be internally learning because this many checkpoints will be gets created. No?
Why do you worry about the checkpoint files? Why do you
Oh,
worry about that one? Tell me. See, you don't do anything with these files. You don't use these files actually.
yeah.
Delta Lake internally using these files actually to read the data or to display the data for you. Why do you worry about how many files it is creating in the backend?
Do we need to configure storage? I mean, configuring any if it is out of volume of data at that point, do we need to configure?
Oh, no, I didn't get you. Come again.
Suppose it is creating, right? If we are creating more than the configured volume of data we are inserting, do we need to configure it here in Unity catalog to increase the storage? Like
I
36, a
uh,
lot of data we are creating, right? So at point
mm-hmm.
of time, it may crash, right?
Okay,
Something.
okay. So,
Uh,
okay, I got your point. I got your
uh,
point. Okay. So what will happen, for that one only, we have vacuum command actually. We'll see whether it is actually cleaning up the metadata files also. But I know the actual data files will get actually um, um, managed in the backend. That we'll try to see in the vacuum command. Okay. So maybe tomorrow I can discuss that one, not now. So we have a command called vacuum. In the vacuum, actually, we'll do that. We'll try to understand that.
Vacuum means rearranging the data.
Yes, indirectly. No, old files will get deleted actually. I
Okay.
mean, the files which are not in use will get deleted. Vacuuming means what? We do vacuum at home, right? Why do we do vacuum?
Cleaning the floor.
Cleaning, right?
Cleaning.
Cleaning
Cleaning.
up the dust and the unnecessary things, right? Same thing will happen here also. Okay, that I can explain maybe later. Not now. Tomorrow I can explain that.
So in that case, only these checkpoint files will remain there. All other files will get deleted. Or
Yes, yes,
uh,
yes. See, this is the metadata only, right? So, see, and that too, you're saying that so many files will get created, right? If there is no enough storage in the volume, what will happen? That's what your question was, right? This
yes,
is
sure.
cloud. This is cloud. You can store unlimited data. Nobody will stop you. Did anybody say you, hey, you have to store only 1 TB of data, 2 TB of data while creating the account?
No, sure.
No,
But
this
yeah.
is cloud. This is unlimited data.
Uh,
You can store petabytes of data also, no problem at all. Okay. So I think still it is running. I think it is completed. Yeah. So that is about uh, you're asking, right? Hey, if at all, if you want to control the checkpoint interval, right, at the table level, you can alter the table. See, we don't do all these things actually. I mean, we don't worry about how many after how many files it is actually getting created. That checkpoint file is created, but because we don't deal with that files, right? So Delta engine is actually managing those things, right? We don't need to worry about that one. And that too, this is metadata. Like size is mostly in K, not even KBs. It is in bytes only. Did you get my point?
sure.
Okay, so this is about insert, update, delete operations on the tables. And what else we need to discuss here apart from this?
So if update multiple columns, how many files got generated?
Sorry, I didn't get to come again.
If you update multiple columns,
Uh-huh.
how many Parquet files and deletion
Same, right?
vectors?
Same concept only. Whether you're updating one
Multiple.
column or multiple columns, concept is same.
Okay, the JSON file itself updating.
That's it. It will simply create that updated record in a separate file. Okay. And say that, okay, going forward, you try to read this particular employee record from this particular file and don't read it from the old file.
Okay, okay.
That's what it is going to remember. Okay. If you want to understand more about that deletion vectors, you can go through Perplexity here. You can just give that to Perplexity. Wide. Okay. Uh, what is the use of deletion vectors in this one, Databricks, right? Databricks Delta Lake, and what happens when we do DML operations? So people may ask you in the interview, hey, before this deletion vectors concept, what used to happen? How they used to manage? I told you already, I've asked you to disable the deletion vectors and I asked you to check the backend behavior. Did you guys get a chance to check that? No, I know you guys are VIPs. You don't get time to do that, all those things. You know what happens? This deletion vectors concept is introduced in Delta Lake 4.0, I guess. Previously, what used to happen, um, let's say we have a Parquet file called um, one one dot Parquet, something like that. Okay, okay. Now let's say we have one more file called two dot Parquet. Okay, let's consider from employee number 1 to 10 is here. Okay, and here 2 to, sorry, not to 11 to 20 employees records are there in this file. Okay, what did I do is I just updated one of the employee salary from 1000 to 2000 from employee ID, let's say 5. Now what happens here? Tell me. In our case, what will happen in the regular case? Hmm. I just updated one file record, that's it. It will remove actually one dot Parquet. Okay, remove. What happened to this one? Remove one dot Parquet. And it adds actually one dot Parquet along with the deletion vector. It adds one dot Parquet along with the deletion vector, and it adds one more file, that is 3 dot Parquet. Okay, with updated data. Let's say employee 5 salary got incremented to 2000. This is what the information it contains. Correct? This is what we understood right so far.
Yes, sir.
Okay. Now, when this deletion vectors concept was not there in the Delta Lake, what used to happen, one dot Parquet is there, two dot Parquet is created. Let's say you're updating the data in one of the record in one dot Parquet. It will simply remove this fifth record. The entire data will be rewritten to new file. Entire data will be rewritten to except excluding that record employee number 5. This entire data will be rewritten to one more file called 3 dot Parquet. 3 dot Parquet. Now going forward, when you do select star from table, it reads the data from this file and this file. What is the disadvantage of this process actually? Unnecessarily, it is making a copies of the same data right here.
Yes.
I mean, same data means, of course, it has excluded the employee number 5, but back and it is unnecessarily wasting the storage, right?
Yes, sir.
That is the reason why. So this is the old approach actually. If you want to can still observe this behavior actually, what you need to do is at the table level, you need to disable the deletion vectors property. That is the reason why they are saying here deletion vectors at Databricks are the storage optimized feature. What will happen in our case actually with the deletion vectors? It is not actually, of course, it is creating the storage as is here, and along with that, only updated records are actually maintained in a separate file. It is not rewriting the entire data from one dot Parquet, right? Are you getting my point? See, in this case, let's consider we have 10 KB of data here, okay, and we have 10 KB of data here. Okay, because each record consider 1 KB. Okay, 10 KB of data here. Now, when you update the record actually, 3 dot Parquet, what is the size here? 9 KB, right? 9 KB or not? Because it is actually eliminating that employee number 5 and it is creating 3 dot Parquet, right? So total how much space we have now here? 10 plus 10 plus 9.
29.
29. What will happen in our case? Now tell me, it removes actually 1 dot parquet. That means 10 kb here. Okay. And it adds 1 dot, removes means 10 is already eliminated. It adds actually this one same file with 10 kb. With 10 kb, that means so far we have net is only 10 kb. Net is only 10 kb. Okay. And 2 dot parquet is there. That is also again 10 kb. 10 kb. Okay. And with additional file 3 dot parquet with updated data, only 1 kb, right? Are you getting my point? And now total, how much space we have here? How much space we have here?
21.
21. So in the previous case, 29 kb.
29.
Now, are we not saving the space here? Storage here? That is what they are trying to say here. Storage optimization feature that improves the efficiency DML operations like delete, update, and merge. Normally, when a single row in a Parquet data file is deleted or modified, the entire file must be rewritten in the old approach. However, with the deletion vectors enabled, these operations mark as affected rows as deleted or changed without rewriting the whole Parquet file. Without rewriting. It is not rewriting the entire data. Instead, lightweight structure, the deletion vector tracks the soft deletes or modifications logically. This is what the conclusion point actually that I've explained so far. Yes, got it. Any confusion?
Nothing. Suppose if we not using deletion vector, then I mean with the first one, third parquet file contains it will remove that updated data, right?
It will remove that.
Uh,
Remove that. Yeah, it will. We did salary we incremented, right? Of course. Sorry, 10 kb only right here. So it will not change, right? Actually.
Correct.
Okay,
That's
with
what.
updated data, third Parquet file will get created, right? With updated data.
We can do with 10 kb only again.
10 kb only, right? So 30 kb will get here, but here
30
21
kb.
kb only.
Yeah.
9 kb difference is there.
Uh-huh.
I thought it is delete operation. Sorry, my bad. That's okay. But ultimately, I mean, you guys understood the underlying concept, right? What
Yes.
happens in the backend behind the curtain.
Got
Okay.
it. Yeah.
So others, are we good?
Yes, sir.
Okay, so that is one thing. See here, table property delta dot enable deletion vectors equal to true. That is what I told you at the table level. When you do this one extended table. Now here in the table properties, actually you can see here deletion vectors true. This is what I was talking. This is what I was talking.
How to update this table properties here?
Alter table set property delta dot enable deletion vector equal to false.
Is it session level or entire?
Entire table level. Table level. We are updating
Table
at the
level.
table level, not at the session
Okay.
level. See, if you don't know that command, simply, okay, you can use this AI assistant here. How to disable deletion vectors for the EMP table. Search it here. Nothing wrong. Nothing harm or nothing wrong in doing this. See here, what they are doing here. Alter table, this table, set table properties of delta dot enabled vectors equal to false. That's it. You can execute this command. Are you getting?
Yes, sir. It's giving Python format.
If you want, you can percentile SQL and you can execute this command as well. That is also okay.
Okay.
By default, I told you, right? PySpark command it will give.
Yes, sir.
So this is about the backend operations. I think we did not cover much today. Okay, I think I'll start that optimize command tomorrow. Let's keep the data as is and I'll discuss that optimize command. Or I can discuss also optimize command at this point of time. Now, the problem is actually, let me talk about the problem statement here. So what is, okay, so we are done with the DML operations case. Now our next concept is optimize. Okay, so why is that optimize came into the picture here? Okay, so what is happening here actually when you do select star from table? So far we discussed about the metadata level. In the metadata level, for every 6 CRC and JSON fields, one compacted file got created here. And for every 36 files, actually one checkpoint file got created here. So that it is avoiding actually reading the small files and the it doesn't impact the performance here. So that is very good actually. That is very good option. Shiva, the same thing is happening at the data level also, right? It is creating hell number of like Parquet files here, right? When you do select star from table, how does it has to pick and choose actually the required files here? Okay, of course, it is picking and choosing only the required files from this metadata, and it has to read actually, let's say, if metadata say that, okay, all my table data is spread across 10 different Parquet files. Then it has to open all 10 different files and it has to close those files and it has to display that records to you, right? Is that correct? Is that correct?
Yes, sir.
Now, in that case, again, it's a headache. Metadata overhead problem again. Small files. Too many files will get. See, I've just created a simple table, employee table, and I just inserting like a 2 record, 3 records like that only. But in real time, every time we do actually these things, DML operations. Did you remember, like in Snowflake, I told you DML operations are costly operations. Why did I tell you that point? It keeps creating the micro partitions in the backend, right?
Yes, yes.
This is the reason for that.
Your storage cost is.
It is unnecessarily adding the storage cost, right? Okay, now coming back to Databricks here. If you keep on doing the DML operations on the table, okay, it keeps incrementing the number of files. It keeps adding the files in the backend. And when I do select star from table and when I do select star from with where condition, it is difficult for Spark or Databricks to open all these like 100 lot of files, and it's very difficult to close all those files. It will take more time actually. More time actually. Then what happens? What we need to do, we have to optimize this. So currently this optimize operation is happening automatically. Okay, I don't know how many times this optimize command ran here. Now let me go and check that one here. Where is that optimize command? When you run the optimize command, what happens, here? Describe extended and the describe history. Yeah, this is what we need to execute. Now let's see.
Shiva, here, do you have any log file to record all these activities?
This is the history. History is tracking everything, right?
Yeah,
Every DML operation you do, history is actually tracking, right? See, it is keep adding here what operation you have performed. Correct or not?
yes.
So it is tracking this one. Auditing is happening here. See here, it is optimizing the data here. See, after certain operations, it has optimized the data. See, if it is not happening automatically, maybe in the latest versions they are doing it automatically. But in the older versions, actually, even in my previous project also, we were running this optimize command manually. Maybe we can run it now also manually. Okay, you know what will happen when you run the optimize command? Okay, let me show you the documentation here so that you'll understand. Is it okay if I extend the class for 10 more minutes or 15 minutes? Or you want me to discuss tomorrow?
Okay.
Okay, it's a small command only. Don't worry. It won't take much time. So in the documentation, let me, okay. What happens when we run optimize command on the delta lake table? Okay. See, this actually fetches the data from the Databricks documentation only. You can happily use the Perplexity. You can believe that. ChatGPT, I don't believe that much, but Perplexity is somewhat better compared to ChatGPT. Okay. See here. It is saying a lot of things actually. The only point that I wanted to highlight is optimize reduces the small file problem. This is what I wanted to highlight actually. Okay. Okay. So running the optimize command in Databricks, Delta Lake compacts the small files and reorganizes the table storage layout to improve the query performance and read efficiency. What is that they're trying to say here? Now, what it does, here in the backend, when you write the optimize command, it will simply copies the data from all these small files. Or recently, if it has created any snapshot of the table, it simply copies the data from that snapshot and the small files that it is supposed to read and loads that data. It creates actually a single file, 1 GB file snapshot. It will try to create. It will simply dump all this data into one single file. So that what happens? When you do select star from table, what happens? It will actually read the data from that single file only. But Shiva, even after creation that single file, what happens to the old file? Old file still remains same. It will not get, they will not get deleted. But there is no use of those files, right? What are we going to do with these files? That is what I was telling you. Vacuum command we need to use actually to remove that unnecessary files. That we are going to discuss tomorrow. For now, you just try to understand. It actually creates a one more extra file, one more extra Parquet file. Okay, and it copies the data from all the small files and dump into that Parquet file. Okay, the size of that file is actually 1 GB. There is a limitation. I mean, limitation means they kept actually, let's say, 100 MB, 100 MB, 100 MB, 100 MB Parquet files are created. Okay, backend. So it creates actually 1 GB file, 1 GB file, and if it is crossing beyond that 1 GB, one more new file, one more extra file will get created. Let's say 1200 MB is there. With 1 GB, one file will get created. With remaining memory, it will create one more file. That means 1 GB memory chunks it is going to create in the backend when I do optimize. Shiva, we don't have 1 GB of data here, then what will happen? That's okay, guys. I mean, 1 GB if I talk in terms of like MBs. If it is in KBs only, that's okay. Less than 1 GB file will get created. No problem with that. But the limit is actually 1 GB here. Are you guys getting it?
Yeah, sure. Like snapshot will get auto. We need to create it, or that 1 GB data
No, we don't need to create that one. You just run.
automatically.
Okay, what we need to do
Mhm.
is we just need to run optimize command here. That's it. I'll write it here. I'll write it
Okay.
here. Okay. Simply what I'll do is sorry, percentile SQL. Okay. Optimize that table, whichever the table you wanted to optimize, right? That I have to copy here and paste it here. The table name is underscore Shiva here. Okay. Just run this one. That's it. That's it. Now, if I execute this one and see what is happening here. See? See, number of files added. How many files it has added? Only one file it has created. Number of files removed, 10. 10 files data it has copied into one file only. Okay. Now files added. Files added backend. It is capturing the metadata, and yeah, that's it. I think in that metadata, what is the minimum value? What is the maximum value? What is that? Everything it is It has captured everything here. Okay, the files added, minimum value, maximum value, everything it has captured. See, it is simply creating one file on top of all the single files, small files. So this is what we.
Shiva, it is telling files removed also 10, right? But we are telling that files will be there, no? Available.
I didn't. Files will be available. It is adding one file going forward. When you do select star from table, it will read only from this file. It will read the data only from this file.
Yeah,
It doesn't care about the other files that are there in the storage location.
yeah. So
Tomorrow
number.
we'll see how to sweep those files.
Okay. Yeah,
Like
here
like
files removed 10, right? So
Ah,
these
like
10
soft
files also
delete.
will be
because
there.
Mhm.
These 10 files also will be there in this one data, right? In data, that files will.
Data will be there still in these 10 files.
Uh-huh.
Data will
Yeah.
not be erased. Once the Parquet file is created, that's it.
Okay.
You cannot
Yeah.
modify that.
Mhm.
It is kind of soft delete, right?
Just
Ah,
like a soft delete. Yeah.
soft delete. That's it.
Logically, it is telling a number of files from these 10 files is created a one single file. Like that
One
it is.
single file. That's it.
Yeah.
So in the metadata, it updates it. Don't read the data from these 10 files. Simply go ahead and read the data from the single file. Okay. Okay. If you want, I can show you here. Describe history, right? So percentile SQL. Okay. Describe history. Okay. The table name. Where is the table name? This is the one, right? Now copy this and paste it here. Okay. Let me execute this one. Now see, backend optimize command is ran. See, backend optimize command ran. See here, if I move, why did it say 10 files? Before this one, it has created one optimized file. That means we have the consolidated data here. Okay, and after that, 1, 2, 3, 4, 5, 6, 7, 8, and this file is there, right? Including this file, ninth file. So one more extra file might be there in the backend. So it is trying to consolidate the data from all these 10 files here, and it is writing it to one single file. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Maybe I don't know where is the 10th file came here.
So it includes that file also, maybe.
Maybe. No, it doesn't delete that file, right? Files removed should be only 9, right? In that case, I don't know. But
Shiva,
see, the
అక్కడ
ultimate point is good.
ఎర్ర బటన్ ఉంది కదా, అక్కడ క్లిక్ చేస్తే తెలుస్తుందా పైన డిస్ప్లే
Here,
హిస్టరీ
no, not
అక్కడ
here
పైన
actually.
ఆప్టిమైజ్ కొట్టినప్పుడు డిస్ప్లే హిస్టరీలో మీరు అదే నెంబర్ ఆఫ్ ఫైల్స్ డిలీటెడ్ యాడెడ్ నెంబర్ ఆఫ్ ఫైల్స్ రిమూవ్ 10 అని చూపించింది కదా,
Yeah.
ఇక్కడ యారోస్ ఉంది, యారోస్ అక్కడ
Okay. So this is just a path here. No, you will not come to know that. Which files it has marked that that it will capture in the back. Number of columns 9. Number of total scheduled task 1, clusters parallelism. I don't know that where is the 10th file came here. That's okay. That's okay. We don't need to much worry about that file. That's fine. But ultimately it is, see, point is actually here. It is actually copying the data from all the small files and dumping it to one single file. So that whenever you do select star from table, it actually takes the data only from that single file going forward.
శివ ఒకసారి దాంట్లోకి వెళ్ళరా డేటాలోకి ఇప్పుడు కొత్త ఫైల్ క్రియేట్ అయి ఉంటుంది కదా పార్కే ఫైల్
Definitely. Definitely. So let me refresh this one, but I don't know which file got created here. I can tell you only by doing this last modified here. So the highest size is having the more size is actually there in this with this file only. So I'm assuming that this file could have added this.
Yeah, correct. Yeah.
Okay. So
Oh,
if you
Shiva,
want to, go ahead.
in real time, we'll not run that command, right?
No, we'll run.
But anyhow, Databricks itself, it's running, right?
It is running.
Optimization.
I have to confirm that one. Maybe tomorrow I'll confirm that one, whether it is doing a optimize command automatically or not, or do we need to see, usually as per my understanding, periodically, at least in a week, weekly once actually, we need to run this optimize command so that backend the performance will get improved. That is what my understanding is actually.
While doing DML operation, optimize will cause
Optimize is happening automatically.
performance issue.
No, you'll not get any performance issue. Optimize will happen after that DML operation, right? Not parallelly, right?
Yeah.
It can take care in the back end. You don't need to worry about that.
We can control, right? Optimize.
Yeah. See here, what files it has removed, it is trying to show that one here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10th file also there. And it has created this file. What are all the files are there that it is trying to give here? What files it is deleting? If you want to analyze this one, you can analyze this one, no problem. And it is adding this file on top of that one. See, if you want, you can analyze this one. See, in this file, see here, everything, total number of records are 101 here. All the records are actually written to this file. The minimum value is this one, maximum value, everything is stats are captured here again. See how beautiful it is capturing that. Okay. Is it clear?
Sure.
Yeah, so this is about the optimize. Tomorrow we'll see that vacuum command. Yeah. The compacted also it is copied the same thing. Going forward, it will simply take the data from this one only. Okay, yeah. So that's all, guys.